Okay, so we're going to have a look at another question coming from the 2022 HSC Standard 2 Maths paper. So this is question 34 in this paper. So we're told a composite solid is shown. The top section is a cylinder with a height of 3 and a diameter of 4. The bottom section is a hemisphere, half of a sphere, with a diameter of 6 centimeters. The cylinder is centered on the flat surface of the hemisphere. Find the total surface area of the composite solid in centimeters squared, correct to 1 decimal place. All right, so the way we're going to do this problem is we're going to break this up into a series of different surface areas and then calculate the surface areas separately. So first we need to know the surface area of the spherical portion down the bottom. So we have half of a sphere down the bottom. This bit here, it has a radius of 3. So the radius in this case is equal to 3 centimeters. The surface area of a sphere is equal to 4 times pi times the radius squared. So this means the surface area of 1/2 of a sphere is 1/2 of this. So this means that for this first bit of surface area, we've got, so we'll call this surface area 1. This is 1/2 times 4 times pi times 3 squared. 4 times 1/2 is 2. 3 squared is 9. This is 18 pi. And this is units squared. We're going to leave it exact like this, and then we're going to numerically simplify this at the end. So this is our first bit done. The second bit we want to do is the little ring on top of the sphere. So we have not a full circle on top of the sphere, but a little annulus. This little bit around the outside. This is sometimes called an annulus or a ring or something like that. So it has an inner circle and an outer circle. The outer circle has radius 3. The inner circle has radius 2. We can see this from the diagram. So the area of this annulus is going to be the difference between those two circle areas. So surface area, we'll call this shape 2, is equal to the area of the big circle, which is pi r squared, that's 9 pi, minus the area of the little circle, which is pi r squared, which is pi times 2 squared, which is 4 pi. 9 pi minus 4 pi, this is 5 pi. So this is the area of this annulus, this little disc around the outside of the smaller circle, but inside the bigger circle. So this is our first two done. This is the first one. This is unit squared. This is the second one. Now we just need the outside of the cylinder and then the top of the cylinder. So we can do these separately if we want. The surface area of a standard cylinder, is equal to 2 pi r squared, which is one circle on the top, one circle on the bottom. That's why there's two of them, plus 2 pi r h. So the 2 pi r h in this case is the bit around the outside. So this is for the two circles, the one on the top, one on the bottom. This is for the sort of rectangular bit that goes around the outside. If you unwrapped the outside of a cylinder, it would be a rectangle. So what we can do is we can modify this formula. The surface area of a cylinder that has only one circle is going to be, so surface area that we care about, surface area 3, is just going to be pi r squared plus 2 pi r h, because it's a circle, but it's missing the circular bottom. That no longer counts. So we are going to get that surface area 3, this is the composite of the two involving the cylinder, is pi times 2 squared plus 2 times pi times 2 times 3. So this is 4 pi plus 2 times 2 is 4 times 3 is 12 plus 12 pi. So this is going to be 16 pi. And this will be in units squared. So therefore, the total surface area will be the sum of all three of these. 18 pi plus 5 pi plus 16 pi. 18 pi plus 5 pi plus 16 pi. 18 plus 5 is 23. 23 plus 16 is 39. So this is 39 pi. Now the question has told us to present this correct to one decimal place. So we get the total surface area is therefore, now use our calculator, the very last step, 39 times pi is 122.522 ... So this is what we get for evaluation. So therefore total surface area is 122.5 centimeters squared, because this is all in centimeters, when rounded to one decimal place. And this is the answer that we're after for this particular question. There's a few different ways you could do it. This was one way to do it, where we did a few different sections individually. You can take the total surface area of a hemisphere, if you have that formula, total surface area of a cylinder, then subtract two of the circles. That'll work as well. You could do the cylinder in two separate parts. That would work as well. So there's a bunch of different things you could do here. This was one of them. So let's go through the marking. You get 1 mark for calculating any relevant areas. So if you have a relevant area, one of the circles outside the cylinder, the annulus, the half of the hemisphere, something like that, or some equivalent working, you'll get a mark. For a second mark, you need to calculate the curved area of the cylinder or of the hemisphere. So you'll need the cylinder outside or the hemisphere section. For the third mark, you'll need to calculate the curved area of the cylinder and the hemisphere. So now you'll need quite a lot of working, pretty much all of the areas individually. And for the fourth mark, you'll need to correctly evaluate that and round to one decimal place. So this is how question 34 works, and this is an approximate rundown of the marking.